Welcome to qnawire.
So here we have a board, rectangular plate here that's attached to two links, um, and it is rotating. These two links are not touching each other and they're moving separately. So initially they're each 0.2 meters away from their zero position. B is moving upwards, A is moving to the left at this point, and it's rotating at 2 radians per second. And we want to find the angular velocity of the rod A0 and dB or BD. So a couple things we can do is first know that the length, so L of A0 equals 0.6 meters and L of BD equals 0.5 meters. So we know the absolute length of those two rods. And the next thing we can do is find the length of the smaller portion. So between C and A, that would fairly simply just be 0.4 meters. And between C and B, that would just be 0.3 meters. So that just helps us with a little triangle there. We can calculate the velocity of A based on this omega. So the velocity of A would equal that omega p, where p is the plate, times the length from C to A, so LCA. If we put numbers in for that, that gives us 0.8 meters per second to the left. We can then calculate the angular velocity of the link between O and A, so that bar. So we know that the velocity of A will have to equal the angular velocity of that link A0 times the length of A0. We can solve this for that angular velocity. A0 would equal the velocity of A divided by the length, which would be 0.8 divided by 0.6, or about 1.33 radians per second. We need to know what direction that is moving in, and that's pretty simply the counterclockwise direction if it's held in place at O. So we want to do the same thing for BD then. We find the velocity of B, which would just be omega p times the length of that CB portion, which would be 0.3 times 2, which will give us 0.6 meters per second. Then we know that VB has to equal the angular velocity of the length of BD times the total length of BD. In other words, that angular velocity would equal the linear velocity divided by that total length. The linear velocity of that we just found was 0.6 meters per second. We divide that by the total length of 0.5, so that's 0.6 over 0.5. In other words, that's 1.2 meters per second. And again, if D is held in place, that means it's going to rotate in our counterclockwise direction.